All right, we're going to finish up chapter 8. We got a couple practice problems to do. We're going to solve nonlinear systems of equations algebraically. So next I have the system x squared plus y squared is 7, and x squared minus y squared is 25. Keep glancing over here just to make sure I start these out right. Now, remember, we can use the same processes and the same methods from the linear system. So I've got equation 1 and equation 2. And look right here. The y squares are already matching, and they have the same sign. Or, sorry, they have the opposite sign. So if I just add 1 and 2, then the y squares will fall out. So x squared plus y squared, I didn't do anything to them. X squared minus y squared is equal to 25. Now, if you're wondering why do I seem to add more often, it's because subtracting, it's just easier to make a mistake. If you say subtract this equation, if you distribute that subtraction to each term, whereas if you make them opposite signs and add them, that's not the case. X squared plus x squared is 2x squared. Y squared minus y squared plus negative y squared is 0. And then 7 plus 25 is 32. I want x by itself, so it's currently being multiplied by 2. So I'm going to divide by 2, and I'm going to end up with x squared is equal to 16. And what's next? If I want to get x by itself, I have to take the square root of both sides, meaning that x is equal to the positive and negative square root of 16, which is positive and negative 4. All right. So now if you decided you wanted to subtract those two equations at the beginning, you can absolutely do that, and what will happen is the x's will go away, but then you'll be left with 2y is equal to, and that'll be negative 18, and you'll go from there. But so here are the x values that could be solutions. So now we're just going to check them. Okay, so we got to check them in both equations, and I have 4 to check. So I'm going to check. X is negative 4, or sorry, we have 2 to check, and then I'm going to do them in each equation. Equation 1 says x squared plus y squared is equal to 7. X is negative 4, so that's negative 4 squared plus y squared is equal to 7. Negative 4 squared is positive 16. I want y, I'm trying to solve for y, so I'm subtracting 16. I'm always solving for the variable that I don't know. Y squared is equal to 7 minus 16 is negative 9. Y is almost by itself. I'm going to take the square root. And what happened? I took the square root of a negative. Or sorry, you took the square root of a negative number. So what do I have? Positive and negative square root of negative 9, which is positive and negative 3i, which are not solutions I'm interested in. So negative 4 does not work. I don't need to test negative 4 on the second equation, because remember, if it doesn't work for one equation, it doesn't work for the system. It doesn't matter. If negative 4 did work for equation 2, you still would have to check to see if it works in equation 1. And if it doesn't, then it doesn't work. It's not a solution. So I don't actually have to check that one twice. How about 4? What's going to happen if x is 4? Well, it's going to be very similar. I'm going to use the same equation to start out with. It's actually going to be exactly the same result. Why is that? Because when I plugged negative 4 in for x, I squared it and got positive 16. When I plug in 4 for x, I'm going to square it and get 16. And this is the exact same as the step. If I just follow the work there, right? I want to get y by itself. Y squared is equal to -9. Take square root of both sides, but I got to do the positive and negative, which means y is equal to positive and negative 3i, which leads me to solutions that I don't want. So, found two values of x that worked. Then I plugged them into one of the equations. Both of them led me to complex solutions. So that means this system has no solution. All right. Next. And what does that mean? What does this mean if I were to graph this? What do you think this looks like? All right, well, one of these is a circle, and the other is not. X squared plus y squared equals 7. There's my circle. X squared minus y squared equals 25. And what do I have? What do you expect it to be? Well, okay. So the x squared minus y squared is equal to 25 is the blue line. The x squared plus y squared equals 7 is the red. And look at that, they never intersect. So if they never intersect, there are no solutions. That's exactly what we found to be the case. All right. Now let's go on to logs. All right, so and describe the properties. Sorry. This one has no solutions, so that means it is inconsistent, but still independent. Up above, we have the problem we did at the end of class was consistent because it has one solution, and independent because the equations are different. Next, we have the log. So what I would love to do, I don't really want to deal with substitution here. Elimination looks like a much better method to me. So equation 1, equation 2. If I multiply equation 2 times 2, I'll be able to get rid of the log y's, right? Because I'll have 2 log y minus 2 log y. So equation 1 does not change. Log of x plus 2 log of y equals 5. And then 2 log of x. Sorry, I said multiply that by 2, so that makes it 4 log x minus 2 log y is equal to 2 times 0 is still 0. And we're going to add. You always see me add here if I can, because it just makes it where I don't make mistakes. Log of x plus 4 logs of x makes 5 logs of x. 2 log y minus 2 log y is 0. And then 5 plus 0 is 5. 5 log of x is equal to 5. I want to solve this for x. So I get the log on a side by itself, and I get it completely alone. So now I have log of x is equal to 1. And what is this? This is a logarithmic equation, which I can convert to exponential form. There's no base written here, so there's an understood base 10. So this says, what power do I raise 10 to get x? And the answer is 1. So 10 to the first is equal to x. So that means x is 10. If x is 10, I got to check it in equations 1 and 2 and see if it holds. So we're going to check x equals 10 in equation 1. Equation 1 says log of x plus 2 log y equals 5. Swap out the x for a 10. Log of 10 plus 2 log y equals 5. Log base 10 of 10 is just 1. What power do I raise 10 to get 10? plus 2 log of y is equal to 5. And what do? I have a logarithmic equation. I get the log on a side by itself, so subtract 1 from both sides. I want the log totally by itself, so divide both sides by 2. And what have I got? Log of y is equal to 2. Rewrite that in exponential form. That means 10 raised to the second power equals y, which means y is 100. Now, if this is x is 10, x is 10, y is 100 is a solution, then when I plug in 10 for the second equation, I'll get the exact same answer. Do I? Let's find out. Equation 2 says 2 log of x minus log of y is equal to 0. I know x to be 10. And the same process is going to apply here. Log base 10 of 10 is 1. And remember the goal here. Get the log on a side by itself. So I'm going to add log base y to both sides. And the only reason I'm doing that is that way both come out positive. If I were to subtract 2 from both sides, then divide by -1, the same thing would happen. So that's 2 is equal to the log of y. Rewrite that in exponential form. I raise, what power do I raise 10 to get y? 2. Y equals 100. I get the same thing in both. So that means my solution set contains the single point 10, 100. All right. So let's keep moving. This problem looks a lot like the problem we saw before. One of these is a line, one of them is not. And it's literally the same thing on the left side in both. It's just the right side is different. So let's find out is it always the case that a circle and a, not a parabola, or that circle and that non-circle always miss each other, or can they intersect sometimes? So x squared plus y squared is 13, x squared minus y is 7. Oh, wait a second, look at that. This one's not exactly the same, because look at the second equation, or look at equation 2. Equation 2, instead of having x squares and y squares, it has x squares, but it doesn't have any y's. So what's the easiest thing for me to do here to get rid of one of these variables? It would be to subtract, which you know I don't like doing because it means you open up yourself to errors, but let's see if we can do it right. X squared plus y squared is equal to 13. X squared minus y is equal to 7. And then I subtract that. Remember that subtraction has to get distributed. So x squared minus x squared is 0. Y squared minus y squared minus negative y, y squared minus negative y becomes y squared plus y. And then on the right, 13 minus 7 is equal to 6. All right, well, I got it to one variable. That was the goal. This is a quadratic. So how do I solve quadratics? I get everything on one side and see if it factors. How do I get everything on the same side? Subtract both sides by 6. And now I have y squared plus y minus 6 is equal to 0. Does this factor? Yes, it does. Two numbers that multiply to -6 and add to 1. Those are positive 3 and negative 2. And then by the zero product principle, if two things multiply to 0, one is 0 or the other, which means y is -3 or y is 2. All right, so we're going to check both of these. So let's check -3 for y into equation 1. Equation 1 says x squared plus y squared equals 13. Swap out the y for -3. Now I'm just going to jump ahead 2 steps. -3 times -3 is +9. And now I'm solving this for x squared. Subtract 9 from both sides. X squared is equal to 4. And then take square root of both sides. But remember, I'm taking the square root of a number, so I have to consider both the positive and the negative results. Square root of 4 is 2. So that's positive and -2. We saw this before, right? When x is 2, y is -3. When x is -2, y is -3. So we could have 2 solutions here if equation 2 gives me those same results. Let's find out if it does. X squared minus y is equal to 7. But I know that y is -3. Okay. X squared minus -3 becomes +3. And what else do? I subtract. Wait a second, no. I went ahead and did something in my head I shouldn't have. Minus negative becomes plus. Now I want x by itself. Subtract 3 from both sides. Take a square root. Remember, when you do, you gotta do the plus minus. So that means I found x to be positive and -2 in this system, in equation 2 as well. So what does this mean? This means that both of these x values are valid solutions. So that means when I have +2, y is -3, and when I have -2, y is -3. So I have the result. I resulted in 2 different answers for just one value of y. Let's see if we can get some freebies with my other y value, and that was +2. So if I check +2, I'm going to go to the first equation. X squared plus y squared is equal to 13. X is 2, 2 squared is 4. Subtract 4 from both sides. X squared is 9. Take square root of a number. You have to consider positives and negatives, so that's plus and minus 3. Hey, we've seen that before. So one of them gives me back 2 answers. Does the other one give me back the same 2 answers? X squared minus y is equal to 7. X squared minus 2 is equal to 7, which means x squared is 9. I want x by itself, so take square root of both sides. X is equal to positive and -3. It happened again. So this means I now have the points 3, 2, and -3, 2. So this system, instead of having 2 solutions, it actually has 4. So the solution set contains the points 2, -3, -2, -3, 3, 2, and -3, 2. Now, what does that mean graphically? That means that these 2 equations must overlap or must intersect 4 times. Is that the case? Yeah, it is. Plus y squared is equal to 13 x squared minus y is equal to 7. And let's take a look. If I look at this graphically, I have a parabola and I have a circle. Do I have 4 intersections? Yes, I do. Do they match up with the points we found algebraically? Yes, they do. All right. So let's knock out this last practice problem, then we'll do the application, and then we'll be done with chapter 8. So solve this system using any algebraic method of your choice. Okay, so the first one now. The first equation is not linear. The second equation is. We've seen this, systems of nonlinear equations. So what can I do here? Well, adding and subtracting equations 1 and 2 is not going to work, right? This has x, y in it. This has an x and a y in it. I can't add and subtract x, y's and x's and y's. It has to be either the same thing, or they have to have the exact same variable. So they don't, so that means that will not work. But if I take a look at 2, this is already solved for y. So I'm going to take that and sub into equation 1. Equation 1 says x times y is equal to 1. If you're looking at that thinking that's not a real equation, I understand what you're saying, but it is. So that means x times 2x plus 1 is equal to 1, because that's the sub, right? The substitution, equation 2 says y is the same thing as 2x plus 1, so y gets swapped out for 2x plus 1. Distribute on the right, 2x squared plus x is equal to 1. And it's a quadratic, get everything on the same side. 2x squared plus x minus 1 equals 0. Does this factor? Yes, it does. If you want to, because this is the way I've been teaching it, if you want to come out to the side and do the bottoms up method, because the leading coefficient is not 1, you're absolutely allowed to do that. Just don't forget the step. Take a and c, multiply them, and then does this factor x squared plus x minus 2? Yes, it does. It factors into x plus 2 times x minus 1, but remember, once you have that, you then have to come back and divide your answers by whatever a was from the beginning. So that means I now have, this factors into x plus 1 times x minus 1/2. X minus 1/2, that's the same thing as 2x minus 1. So two things multiply to give me 0. One of them has to be 0. So either x plus 1 is 0 or x minus 1/2 is 0, which means x is negative 1 or x is 1/2. And now what do? Those are possible solutions, so we plug them in to our equations. So let's check. Let's do it in a different color. We're going to check x is equal to negative 1. In equation 1, equation 1 says x times y is equal to 1, and then substitute x is negative 1. So what is y? I want y by itself. It's currently being multiplied by negative 1. How do I unmultiply something? What's the opposite of multiplying? Dividing. 1 divided by negative 1 is negative 1. So that leads me to a point, negative 1, negative 1. All right. So, did I do that right? Yes, negative 1, negative 1. Next, that's equation 1. How about equation 2? Does equation 2 lead us to the same answer? Equation 2 is y is equal to 2x plus 1. I know x to be negative 1. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. These match, so x, so that means the point negative 1 is a solution for this system. Okay, what's my other x? That's 1/2. So for equation 1, I have xy is equal to 1. x is 1/2. I want to get y by itself. It's currently being multiplied by 1/2. And I'm going to clear the fractions. I'm going to clear the fractions by multiplying both sides by 2. And I'm going to find out that y is equal to 2. And then the question is, does this hold for equation 2? Equation 2, y is equal to 2x plus 1. But x is 1/2. 2 times 1/2 is 1. 1 plus 1 is 2, so that means the point 1/2, 2 is also valid. So my solution set has 2 points, and they are -1, -1, and 1/2, 2. All right, so systems of equations are not going to defeat us. We got this. The last problem in chapter 8 is an application problem, and what we're going to do is we're going to run into this equation. I'm going to write it up here at the top. It's an exponential equation. P of t is equal to P naught times e to the k t. All right, so P naught is the population at time 0. So instead of having a number here, typically when you get a problem like this, they'll say this is bacteria growing exponentially, so you'd start with 50,000 or 10,000 or whatever, and then as time passes, they would grow. I don't know how many there are to start with. And I also don't know the growth factor, which is k, right? It's my growth or decay. So what do I know? This equation is going to give me an estimate of what is the population of the bacteria for the first 72 hours. After you reach 72 hours, it appears the bacteria do not grow exponentially anymore. So t is time, and it is in hours since the culture started, and I have 2 points of interest. The population of the bacteria is 60,000 after 7 hours, and 80,000 after 12 hours. So what do I know? I know that the population after 7 hours is equal to 60,000. And I know the population after 12 hours is equal to 80,000. The first question asks us to find k. So let's go do that. So how am I going to find k? Well, it turns out I'm going to plug in everything I know because I need to find 2 things. I need to find P naught, which is how much did I start with, and I got to find k, which is that growth or decay factor. So let's plug in everything we know to P of t, and what is it that we know? So we know that at 7, when t is 7, P of t is 60,000. So let me just make a little bit of space here and get you everything together. So this means what? This means that 60,000 is equal to P naught times e to the 7k, because the t is up here, the t is 7. So I got 60,000 is equal to P naught e to the 7k. And the other data point tells me that 80,000 is equal to P naught e to the 12k. All right. So I don't have 2 things that are equal, but I could solve both of these for P naught, because it's the same number on the left and the right. If I solve these for P naught, the initial value, can't I set those equal? Can't I do a substitution? Yeah. So I want P naught by itself, which means I need to divide both sides by e to the 7k, which means I now know that P naught is equal to 60,000 divided by e to the 7k. Over here, I need to divide both sides by e to the 12k to end up with P naught is also equal to 80,000 divided by e to the 12k. Why did I do all this work? Okay, why in the world did I do that? Because now, what do you have? Now you have two different values for P naught. So if P naught is equal to 60,000 over e to the 7k and P naught's equal to 80,000 over e to the 12k, doesn't that mean that 60,000 e to this divided by e to the 7k is equal to 80,000 divided by e to the 12k? Absolutely. The ratios have to be the same. So what do? Well, cross multiply, because everybody loves cross multiply. So cross multiplication leads me to, and I'm drawing an arrow here just to indicate this is a result. This says that 60,000 times e to the 12k is equal to 80,000 times e to the 7k. And now look at that. What do I have? I now have one variable and one equation. So now I just need to solve this for k. So I'm going to get the exponentials on a side by themselves and everything else to the other side. So I'm going to divide both sides by 60,000. That'll get rid of the 60,000 on the left. So now I have e to the 12k is equal to 80,000 divided by 60,000 is 8 divided by 6. I'm just reducing. And then 8 divided by 6 is 4 divided by 3. 4/3 e to the 7k. Now, I need that e to the 7k to go to the other side. It's currently multiplied by 4/3, so I'm going to divide by it, e to the 7k. Divide e to the 7k. And why is that making me happy? Because when I divide and I have the same base, I get to subtract the powers. E to the 12k divided by e to the 7k is the same thing as e to the 12k minus 7k, which is e to the 5k. And now I just need to get this power down. What do? I use the power rule for log. I'm going to take the natural log of both sides. And that's going to leave me with what? The natural log of, since I did it for the power rule, the 5k comes out front. And then this is left as the natural log of e is equal to, I took the natural log of one side, I have to do it to the other side as well. What is it? Natural log of e? That's just 1. So I have 5k is equal to the natural log of 4/3. I want k by itself, so divide both sides by 5. Do not plug in natural log of 4/3, round it, and then divide it by 5. Do this all in one step. Natural log 4/3 divided by 5. And that is 0.575. So that's going to go to 0.58. So we're going to estimate 0.58. So there's my growth factor. All right. Looks like we needed a lot more space than I had given us. That's okay, because we can move things. So we found the constant, and I knew to do 3 decimal places because that's what it was directing us to do. So k is approximately 0.058. So what does that mean? Well, now instead of just having p of t is equal to instead of having p of t is equal to P naught e to the kt. Now I know that P of t is equal to P naught times e to the 0.058 t. It's still not perfect because I don't know my initial value, but that's what they're going to ask us on the next question. So, well, from before, I know P naught is equal to 60,000 divided by e to the 7k. Right? It's also equal to 80,000 divided by e to the 12k. All in one step on your calculator if you can, and you're going to get approximately 39,978.6. Round this to the nearest thousand, and the thousands place are this 9, right? So look to the right, that 9 means go up. So my initial population is 40,000. All right, once you find K, the problem goes quickly. All right, so now what do I have? Now I've gone from an equation that just had a variable for the initial value and a variable for the growth factor to a full-fledged, fleshed out exponential equation with an application. So there's my equation now, all that work to get me here, and then the last question is determine the time it would take to reach 300,000. So that means if P of t is equal to 300,000, find t. I could not do that step before because I had too many variables, right? I didn't know k, I didn't know p naught. Well, now I know both of those, so that means on the left-hand side, P of t gets swapped out for 300,000. On the right, K is there, and then T is there. Can I solve this for T? Absolutely, because I know how to get powers down from the exponent. So I want to get T by itself. Anytime you have an exponential equation and you're trying to solve for a variable in the exponent, first thing you do is get that exponential by itself. 300,000 divided by 40,000 is going to leave me 30 over 4, which is 15 over 2. We'll do that on the next step. That leaves me e to the 0.058 t. Let's reduce 30 over 4 to 15 over 2 just to make life a little easier. 0.058 t. And now I have my exponential is equal to some number. I want to get the power down. So to do that, I need to take the natural log. If I take the natural log on the left, I have to take it on the right to maintain equality. And the whole purpose of that is so that t can come out front. So I now have the natural log of 15 over 2 is equal to t, excuse me, got to bring the whole exponential down, 0.058 t times the natural log of e. Well, the natural log of e is 1, so you really just have the natural log of 15 over 2 is equal to 0.058 t. I want t by itself. It's currently being multiplied by a 0.058, so I need to do that on both sides. And I find t to be the natural log of 15 over 2 divided by 0.058. When you do this, you're going to find t to be approximately 34.74, and the answer tells you to round this to the nearest hour. So t is approximately 35 hours. Does this number make sense based on the information that we know? Okay, well, what do we know? We know that the 2 points that we had, hours. So the 2 points that we had said after 7 hours we had 60,000, and after 12 hours we had 80,000. So after 35 hours we have 300,000. Yeah, if it wasn't going to make sense, it would be something like after 35 hours you have less than 60,000 or less than 80,000. So if you got this wrong, it would have shown up pretty obviously right here. And that's chapter 8.